Hello, this time we're going to look at bonding this week. So if you were taking some notes, I'll be putting my big heading is bonding, which is the key idea of chemistry. This is basically what chemistry is all about. So if we're looking at bonding, the idea is that every atom wants to have the same electrons as its closest noble gas. The noble gases themselves have a perfect number of electrons. Putting in quotation marks, it's sort of the most stable arrangement. Don't know why I changed colour there, my apologies. Alright, so let's pop this down. That's the basic idea. I haven't spelled number properly. There we go. So let's take a couple of atoms. Let's take magnesium and chlorine. Actually, I might first of all do calcium and fluorine, or potassium and fluorine. I've changed my mind. Will I do potassium and fluorine? E.g., potassium and fluorine. What happens? What happens when they get close to each other? Well, potassium, at the moment, if we write potassium has got 19 protons, (20 neutrons. And on the outside, potassium has got, therefore, 19 electrons. So we'll draw 19 electrons. Let's write a little K there just to remind ourselves that we're talking about potassium. And then we go to fluorine. Fluorine in the nucleus has got 9 protons and 10 neutrons. Which means on the outside it's got 9 electrons. And that is fluorine. Now, if you have a look at your periodic table, the closest noble gas to potassium is argon, and argon's got 18. So potassium wants to get rid of 1 electron so it can go back to 18. The closest noble gas to fluorine is neon. Neon has got 10, so fluorine wants to gain an extra electron, grab one, so it can have 10. So all that basically happens is when they form a chemical bond, potassium will go back to 18 and fluorine will go up to 10. That means that fluorine will end up getting a negative charge. It'll be a 1 minus charge because it's got an extra electron now. So it'll be charged, and the potassium has lost one, will be a 1 plus charge because now it's got more protons and electrons. And because they're now charged, the potassium and the fluorine will stick together, and you can see potassium fluoride is a crystal, and in potassium fluoride the potassium atoms are right next to the fluorine atoms and the fluorine atoms are right next to the potassium atoms. So that's the principle of bonding. We'll do one more so you get the idea. I'll just go to the next page. This time in your notes you might look at magnesium and chlorine, so we get the idea of what happens when one atom wants more electrons than another atom can give, because that's when our formula gets more interesting. So magnesium goes 12, 12 and 12. It's a nice easy number. Neutrons and 12 electrons on the outside. That's our magnesium. Chlorine has got 17 protons, 18 neutrons, and 17 electrons on the outside. So, we have a slight problem here. Magnesium's closest noble gas is neon, which is 10, which means magnesium wants to get rid of 2 electrons. Chlorine's closest noble gas is argon, which has got 18. So chlorine wants to get 1 electron, so it can have the same number of electrons as argon. So magnesium wants to give 2, but chlorine can only accept 1. So how do we solve the problem? We solve the problem by taking this chlorine atom and then using another chlorine atom, so that in actual fact one of the chlorine atoms will take 1 and the other chlorine atom will take the other one. So we grab a second chlorine atom. So this one's also got 17 electrons. So now it's a doable scenario. Both chlorine and each of the chlorine atoms gains 1 to go up to 18, so grabs 1, and the magnesium can lose its 2 to get to 10. They're all happy Vegemites now. Magnesium is like neon on the periodic table, which is a noble gas. It's happy. Chlorine is like argon as far as electrons go. It's happy, and everybody's happy. So each of the chlorine atoms has gained 1 each, and the magnesium has lost 2. That means that the charge on the magnesium is a 2 plus charge, because it's lost 2, so there's more protons. And the charge on each of the chlorines, each is a 1 minus charge. That makes the formula for magnesium chloride 1 magnesium atom and 2 chlorine atoms. So this becomes the formula. And this is the reason why almost all chemical formulas have simple numbers, because in this case magnesium is giving 2 out and chlorine is accepting 1 electron each, so you need 2 chlorine atoms. So it'll tend to always be simple numbers, like 1 magnesium to 2 chlorines. If it's a different compound, it might be 1 aluminium to 3 chlorines, or it might be 2 aluminiums to 3 oxygens, but it's always simple numbers basically. Okay, let's go and look at our second topic for the week. This is a more advanced topic, and this is to do with electron shells, which is another way of explaining why these noble gases are very special elements. Even though they are boring, they don't combine with anybody else, they are special because there's something special about their electron shells. When we said, for instance, that an element like fluorine has got 9 protons, 10 neutrons, and 9 electrons, there is a kind of order for how these electrons are organised. They aren't scattered randomly. And if we actually draw the atom out fully, what we find is that you have your 9 protons and your 10 neutrons, but the electrons are organised in shells. So if I use a dotted line to represent these shells, in the first shell there are 2 electrons, and here I'm going to draw the electrons like we did last week, so you can see them easily. And then in the next shell, out here, are the remaining 7. So there's a kind of filling order. 1, 2, 3, 4, 5, 6, 7. So the basic rules are that the first shell, which we call the K shell, can fit 2 electrons. And once you have more than 2 electrons, you go to the second shell, and that can take the next 8. So that can fit 8 electrons. Then if we go further down, the third shell, the M shell, can fit 8 electrons before the next shell starts filling. And I'm telling you a slight lie here. The M shell can actually fit 18. There's a kind of weird filling order. Whoops. I keep on touching the side of my iPad and then I can't write anymore. So the M shell can actually fit 18 electrons. So let's move all this stuff up. And so that, therefore, if you go and have a look at your periodic table, all noble gases H electrons in their outer shell, except for the first one. Except for helium, helium's the only real exception to this rule, but helium itself with its 2 electrons has a full shell. I hope this helps you, and this is really our theory for the week that should help you do all of the tasks that you've been given to do.